Very much. I hope everybody's doing well on this horrible Friday morning. Um, I guess we need the rain and the weather right before we go head into winter. So thank you everybody for joining. We really appreciate your time. I'm going to be going to take you through our product strategy specifically for our IT product. Now, for those of you who don't know, in H3C, we split the products up into two separate groups. One is called IT, and the other one is CT. CT is typically for connectivity technologies, which is all the networking. And in this case, the IT product will refer to our server offering, storage, and also all our solution offerings like hypervisor, HCI, cloud, and so forth. So, with that, yes, thanks everybody. Like I say once more, let's uh, let's get this let's get this body started so I can give you the rest of your Friday. All right. So as I've said before, my name is Christo. I am the SE for the IT portion of the H3C business. There's supposed to be a nice little picture there in that round circle of me, but I decided I'm not going to spoil you or scare your kids today. It's way too early for that on a Friday morning. But let's jump right into it. So let's have a quick discussion, and then um, for everybody that's been in the industry for a while, you would see that um, the way that we look at compute these days have changed quite a bit from where we come from. Um, general Generally, a single vendor is no longer what customers are looking for. They're looking for diversification in their business. They're looking for different ways to achieve outcomes. And there's a lot of people that do not like to be locked into a technology, whether that be a simple chip vendor, AMD versus Intel, or anything like that, or other platforms, even to the point where we talk about x86 and ARM CPUs. We see ARM CPUs coming, and they've got a huge impact on very nice specific workloads, and then not to mention the huge impact that you know fast memory. And when I talk about fast memory and fast processor, I'm talking about the kind of stuff that we use for AI. It's also become very important for customers to stick to something that is an open standard, something that everybody can connect to, everybody can speak to, and it's easy to build on top of that environment and expand that environment into complete different, uh, you know, positions and places in the IT strategy. Let's think about, for instance, with not just IT, but talk about OT, operational technologies. People start working into, and they want to expand the workloads into OT, operational processes, SCADA, those kind of things. Um, the other thing that we need to understand is that the biggest enemy that we have these days is, specifically in South Africa, okay, let's be honest, is the cost of energy. Um, that is becoming a massive challenge for us. Um, we've never ever in what I've never ever seen the cost of electricity go down. It's always been going up. Um, so that is put almost like a check on things and say, well, if I went out there and I bought a server, I would always buy the one with the highest clock speed and the one with the highest amount of cores because the density and so on. But is it really what I need? So people are really looking at the way that they are purchasing and procuring resources. It is a lot more fit for purpose. Um, those those kind of purchases now. The big bang approach is really not. is really not the approach anymore. So if you think about it, the raw performance is no longer a metric when it comes to customers. It's more about the efficiencies and what can I get for that watt of power, and then how do I expand on that watt of power if I want to go forward. Then, when all that is said and done from a management perspective, it's become even more important to be able to manage, and more important to actually see what is going on, because we can anybody can promise, oh, you're getting a reduction in the cost of your electricity because we're not using that much power. But how would you know before you get the bill? That's the first question. The second one is, how do you actually make sure that you're not using resources and things that you don't need to? So the management and the way you operate this is becoming more and more important. There is also a different side to it, and that side is the fact that the operations and the management, that used to be something that you didn't care if people could see that, and that is becoming very, very important to protect. And therefore, if we look at things like encryption, and you look at things like secure ways of connecting to your systems, and make sure that everything's running perfectly, but those becomes IP, it becomes intellectual property, the way that you manage and the way that you maintain your systems. Okay, so where do we start? Well, we as H3C, obviously being very proud of the fact that we are an open standards product, we don't have anything that is proprietary, or let me rephrase that, very little. And if I say very little, I'm talking about very, very specific instances of product that is proprietary to H3C. I always like to tell people, we play nice with everybody. Okay, as long as you want to play nice with us, we will play nice with you. So if we look at the launch of the Intel Xeon Generation 6 CPUs, how do they actually assist us in this transforming of the data centers? And it becomes a very interesting topic if you start digging into it a little bit. So by the way, for those of you who don't know, the way that our service map back into the CPUs and the CPU generations, very simple. If it's generation 6 CPU, then we typically will have it in a generation 7 chassis or a 7 server. And that is true for a version 6 and a 5. And you can use that logic all the way through. Thus far we haven't strayed from any of that. Okay, so the first thing is that we got to realize that there's a huge increase in the density that Xeon 6 gives us. So there's a lot more compute power in the same amount of footprint. Lots more cores available that we can use in the same amount of CPU. And why is this important? Well, from a density perspective, rack space these days starts costing you more and more money. The way that you populate your data centers also become more of an art than it is just by throwing machines into a rack. There's a lot of things you've got to think of. There's a lot of things you've got to think of in terms of costs, of power usage, of cooling, all those kind of things. So if we think about it, we all know that there's a bit of an issue right now with memory prices. We know the memory prices have gone through the roof the last few months, actually. But why is that? It's because of the invent of DDR5, DDR6, DDR7 memory, which is very, very fast. We use it a lot in our AI-powered systems. The cost of that went up because of the availability of raw product, first of all. And then the other thing is it's simple demand. Okay. So when it's fast, everybody wants it. When it's cheap, everybody wants it more. When it's expensive, people still want it, and that's the point where we are now, because we can't really go without it at this point in time. Now, when you create an environment like this, you've got to make sure that you have a few things that is in place. First of all, it's got to be compatible. Now, with Intel, we've had a very good track record when it comes to the way that Intel has given us products. They've always been very, very good when it comes to making their product compatible with everything, and they've become the gold standard. With that being said, although we don't mention AMD specifically in the slides or in this session, we also realize that there is a very good place for AMD CPUs in our product, and because again, open standards, we support both of those. Now, Intel recently went and they have when they released the CPUs, they've actually released them in two different, and I want to call it flavors, if we can stick to that for now. So first of all, we've got very high performance CPUs, and then we've got the more mainstream CPUs. If we look at the Xeon 6s with the P cores, P for performance, those were there for designed for performance. Very high clock speed, lots of cores, very low latency. This is typically used when you want to run AI workloads in the HPC business, the high performance compute businesses. These are typically the kind of CPUs that you will use there. Those can typically scale up to about 128 cores, which gives you that density that we referred to earlier. And then also lots and lots of cache, which is available. And obviously, we know the more cache you add to a solution like that, the better they tend to perform. And then leverage off the faster DDR5 memory, which gives you about a 37% increase in performance, also running that pair of memory. Now, if you look at the amount of channels that's available, a lot more memory channels. They feature up to 236 PCI 5 lanes, which means all the peripherals that we plug into these servers typically are much quicker. So, and then we have on the other side, we've got the more, we want to call them the E-cores, and they're mostly for the mainstream applications. This is the kind of compute that we are used to when we were talking about the old way of doing it, the silvers, the golds, and those kind of CPUs typically. Now you'll ask me, so how does this all fit into a strategy talk, right? Because all I've been doing for the last few minutes is just tell you what they are. Well, the thing is, the strategy is where you use them. And the strategy comes into play of understanding that, first of all, they work extremely well together to create a environment of where we have the peak amount of performance, but also the lowest associated cost in terms of power, in terms of cooling, in terms of footprint. So when you build a data center or a solution for a customer, and you are faced with what you are going to be doing to create that environment for them, there's loads and loads of questions now that become a lot more relevant than they were before. I think the approach before was a little bit more of a shotgun approach. We would ask, what are you going to be using it for? Oh, you're going to be using it for that. Okay, here's a general CPU that will do the work for you. With the way that the CPUs have been split up and the way that they will be working going forward in terms of these workloads, it becomes a little bit more tricky, but it becomes a lot more efficient if you size these things correctly. And I think that's the point that we're trying to make. You've got to ask the right questions and sit down with the customer and understand, what exactly do you want to do with these boxes? What exactly do you want to do? And how many of them are you looking at doing these tasks, separate tasks? That way, you can give we can give the customer the correct size of machine for the workload, and he doesn't over or underpay. But more importantly, we don't over or under spec, because that typically sits the key value. Therein sits the fact that your customer will trust you. You become the trusted advisor for them, and you build a relationship with your customers going forward. Okay, so if we look at the breakdown, this is what we have just had a quick chat about. We look at the breakdown of these and typically what they will be used for. It's quite obvious that the B course will be more for the performance stuff. We see if we look at some of those case studies there, oil and gas, meteorology, and so forth, typically where lots of compute and the frequency of the CPUs are important. That is typically where you see those will go in. And then once you look at the more the E course, which is a little bit more widely used for smaller workloads, still available for high compute, but maybe not the necessary clock speed. And remember, clock is what costs money. To get a CPU to clock at a very high clock speed, the pureness of the silicon needs to be very high. That typically costs a lot more money. So how do we translate this into our Gen 7 systems? Well, if we look at the matrix, we can see that we talk about our 3900 CPUs, the 3900 servers, the 3900 G7s, the 4900 G7s, which is our single and our dual socket machines. The 4900 is our workhorse. That's the one that typically compares with something like a HPE, DL380 machine. It is the most common workhorse slash building block that we use. And for those of you who's heard some of my previous presentations will know that I refer to these servers as Lego blocks, because they play important and vital roles in creating different scenarios, different solutions. And at H3C, we use them interchangeably for pretty much everything. We use them for our HCI, we use them for hypervisors, we use them in our cloud solution, and it's always the same kind of product. But the strategy for us now as H3C is to size the machine now correctly, first of all for scalability, and second of all for the right sizing of performance versus cost. Because more than ever before, people are more cost conscious of the machines than they were ever before. And that's down to quite a few reasons. Obviously, as we discussed earlier, the price of memory, which is causing a bit of a problem. But we know that that's cyclic. We've seen this before, where there were other scarcities of silicon and chip shortages, right down to car manufacturers also having struggles with what they could supply at that point in time. But we fix it, and then we go. We carry on with our lives. But the cost of everything is always going to be something. And if you have listened to some of the CIO talks that I like subscribing to on YouTube and so on, the CIOs, the very first thing they talk about is, how can I get more value for the money that I spent on my IT infrastructure? Okay, so if you look on the right-hand side, you'll see that we've got 49s, 4900s, and the 4950s in the case of the AMDs are all leaning more and more towards the GPU computing side as well. We've got some very nice devices that are specifically designed for AI and for GPU workloads that we will get to in a minute. Just to give you an idea, what we do in terms of putting the right product in the right workspace in order to maximize the customer's minimize his spend, but maximize the value for him. Okay. So if we look at the general server, that's that little block that I was talking about earlier, that Lego block that we were talking about earlier. The performance we get out of the service right now is massive because of the fact that we've got so many cores that we can put into these machines. We've got lots of memory we can put into these machines, very, very fast memory that we can put into these machines. When it comes to the efficiency, we've got very high efficient power supplies. And this all leans back to the strategy and all leans back to the value and the cost of these machines. So the power supplies that we use in these machines are extremely efficient. The loss due to heat and the loss due to anything mechanical is limited to a very, very small amount. So we can achieve about 96%, which is very high, 96% of efficiency in a CPU when it's operating within its sweet spot environmental parameters, the word I was looking for, sorry. So providing it's not running too hot and it is giving the power within its rated power ratings, then, we can expect a very high efficiency level of it. These machines, typically the ones like we see, the 4900 is our 2-socket machine. So we can put a lot of cores, a lot of CPUs into that, 2 CPUs with a lot of cores, and we can then use this for pretty much everything. With virtualization, it can become a very, very cool storage solution as well. If you look at the picture of this specific Gen 7, and I picked this specific Gen 7 server for you guys, you can see the version of the drives that we support now, which is the E3. I think the E3.S's, E3.S, and we've got the E1S, the U2, and then obviously we support SAS and SATA as well. Now, by using these drives, we can fit a lot more storage into a very small rack server. To give an idea, if we use this in our 4700 machine, which is the 1U CPU, we can put half a petabyte's worth of drive space into this machine. Now, this is NVMe based drives, which means they are ultra low power, extremely fast, and with it all, it is still a server that can be used for pretty much everything. It's that little green Lego block that you can put anywhere to plug a hole, and that makes this product, and it makes H3C in itself, makes it that's what we pride ourselves on. We don't have to forklift your devices, throw them out, put new ones in. If we can use an existing device to create a completely new solution for you. If we look at our unified management, when we first of all talk about the value, some of the guys that knows me say, well, no, I always say this, our unified management is a product that is included into our product stack. It's not something that you need to purchase separately. The reason why we do that is because we don't see why you should pay for the management components to be able to have all the information to manage and operate your environment properly. There's no real point in doing all of that. So let's break this machine into a few pieces. For those of you that's never seen one of these things, and when you take them apart, it is quite an interesting one. First of all, we have this 3D ocean of sensors. Now, this was a phrase that was coined by HPE when they built the Generation 9 servers. At that point, we were still manufacturing their servers for them, so we just decided, we'll keep that, right? And yeah, what does it give us? It gives us the ability to be able to monitor the machine and create an active heat map of what is happening inside of that machine in terms of the thermal properties. Do we have a hotspot? Do we have a hotspot over a power supply that is causing that power supply to be inefficient, which means it's drawing more power? We need to be able to monitor these things and then adapt and fix those problems on the fly. So in this, when we look at our HDM, which is the brains behind this entire thing, we have AI built into it to understand that if we have an issue somewhere, we can come and we can fix that by spinning up a fan or making a fan spin slower or redirect the air if we're using baffles or whatever the case may be. So we're using um, optimized fans. The fans that we use are extremely cool. If you've ever seen one of these things, you can't believe that so much technology has gone into just a small little fan. Um, and that's such an important part of how we make these things efficient. And that's it's such an important part in how do we give the customer the ability to manage and operate that environment with the correct data and making sure that the customer can trust the product to be able to deliver what we've given, what we've promised for him. Now, the second thing, I don't have a slide of that at this point in time, but our Generation 7s, and especially the Ultra versions of this, actually supports liquid cooling. So I didn't want to do a lot with regards to the liquid cooling today because I really want to take another session and focus and really drill down into the liquid cooling of um, of how do we actually do the liquid cooling, which is a very cool way of doing things. People, I've actually done one of these previously for a customer, and I happened to have all the sales guys in the room. They had zero technical ability. I was under the impression they were technical guys. And when I started proposing to them, I saw, oops, I've lost these guys because they don't have any idea what I'm talking about. But I brought up the cooling stuff, and everybody was interested because it's such a great technology. So there'll be a focus session on that going forward. Now, what's the big buzzword today? Everybody's saying it. Everybody wants it. Nobody wants to pay for it. It's all about artificial intelligence. So, what has H3C done in terms of artificial intelligence? So, we have created, and this is a box that we will be launching soon. It's not available right now in the international market, but this is the a little bit of a peek into what is actually coming out of the H3C factory. This will be the 5300 GPU server. This is a specialized machine that will be focusing on AI workloads only. Now, I just want to get my laser pointer. There we go. So as you can see here in this picture, this representation of it, we will be able to put 8 GPUs into that machine, and these will be double wide and full length GPUs. This is quite a big box, right? It's a monster box. So in this case, we're not going to be using any riser cards. The actual GPUs will fit directly into the motherboard, um, giving us a much closer and a shorter, um, you know, round trip from GPU to memory to CPU, and obviously back. So this configuration, as you see it here, we have tested it, and it is what we call our AI trillion parameter large model machine. So we are not talking about billions of instructions. We are moving into the trillions of instructions um, for this. So very interesting. Um, this is not just a machine. This is a complete how can I put this in a nice way? It's a platform play. It is something that we want to be using and building complete new platforms on top of. So, not only large language models, that obviously seems to be um, the one that first comes to mind because it's the one that we know, but the amount of flexibility that a machine like this gives us in, for instance, HPC environments, high performance compute environments, even on edge computing environments, becomes complete endless. There's so many things that we can do with a box like this, if you spec it correctly. And with that being said, if you look at the table, you can see there's lots and lots of different ways we can support this. We look at the networking portion to give you an idea. Okay, all the networking that goes into this machine are OCP. So it's that little cards that slots into the machine. It's not a card that goes and takes up a physical PCI slot. We can do up to 400 gigs of that. Okay, which means this server becomes something that is a lot more than just a AI workload machine. This could typically become a storage solution as well. So we can load OneStore or any other storage software if you want to go down that road. vSAN, you name it. We can load anything like that on this machine to give us a extremely high throughput um, storage solution. Now, as you know, H3C doesn't have a dedicated storage solution apart from our distributed storage solution, which is called OneStore. And that forms part of our hyperconverged solution, which we all know as UIS. And that's typically another building block. But we can run OneStore on different machines. We can run it on our 47s, the 4900s, the 4300 servers, and we can also run it on this 5300 if needs be. Now, everything is done with open standards. So if there's any other OEM that wants to integrate into the products that we do, then we allow them to do that. And that way, we can give the customers a flexible ecosystem that gives them choices and that future proofs them in terms of scalability, because we can add these things, add them, scale them out um, to massive amounts. So think of this as right now it's seen as an AI system, but the way that we propose this will go forward is it will become a lot more than just that. Nothing stops you from running virtual machines on a system like this. Might be an overkill right now because of the fact that you're going to pay premium for all those GPUs, but we know these things are cyclic and they sort themselves out. And then when we can afford memory again and the price of NVMe has come down, this solution will become something much more than just that AI solution. So with that, that's the hardware portion, more or less, of what we have to offer. And this is, as you can see, this is teamwork. This is teamwork with Intel, it's teamwork with other vendors, with our OneStore guys. It's a bunch of people that came together to give us solutions. Now, the one that I want to talk to you about, um, oops, that's the wrong way, right? Let's go that way. What I want to talk to you about right now is probably the hottest topic that we have in the industry right now. And I will be surprised if there isn't anybody in the audience that has not spoken to a customer recently um, about their hypervisor and specifically VMware. Now, I know, we don't like slating other uh, OEMs and other vendors, and I'm not going to do that in this one either. But I am going to highlight the kind of things that they manage to not do well, if I can put it that way. So if you think about the price first of all of VMware and the where it went, um, VMware made it very difficult for their customers to stay on that platform because of the cost. They also made it quite public that they only want to deal with the 500 blue chip companies in the world going forward. So public statements were made that they're looking to shrink their customer base and have people um, look for alternatives. But they weren't completely rude about the whole thing. And I will tell you this. This will come out in a slide a bit later. Um, so what we've done is that we've had a hypervisor that we've developed since 2009 that has a strong history of development behind it. Now, again, I'm not going to dive into CAS too deeply because I'm going to do a focused session on CAS, but that will include a demo with live migration, installation, all those kind of things. But I want to highlight CAS. I want to give you this as almost like that, that ad when you go to the movie theater and you sit and you watch the preview of a movie coming. This is going to be the preview reel for CAS. As I want you guys all to come back and have a look at what we really can do with this product. But the customers out there are scrambling like crazy, um, and it's becoming more and more desperate because the way that the renewals with VMware works is once they shut it down, they shut it down, right? It expires, then the product stops working and all those kind of things. So there is a bunch of customers that is scrambling like absolutely crazy at this point in time. And the point that we have is that we have a very good alternate to CAS. But, and this is where the strategy portion comes in, because of the fact that we have got a API that links the two systems together, the strategy, and we make this very clear to our customers when we have a discussion with them, is not to tell them we are here to kick out all your VMware. We are here to tell them we are going to run in parallel with your existing VMware infrastructure. And that's why I've been doing a lot of demos, and the receipt of this, people receiving this information has been extremely positive. And this is where I alluded to earlier. We have an API that sits between the two platforms that was actually written by VMware. So we integrate into them, and then they integrate into us, and everything works. And then when we migrate from CAS, it's a very simple few clicks, few answers, and off you go. I don't want to spoil it. That will be spoiler alert because I want to show you this in the next session so you can see actually how well this works. And most of the customers that we've had demos with, the moment we show them this, then they become extremely interested in the solution, because the biggest headache of anybody that's sitting in a VMware situation is, how do I move the data? I've actually been asked more. People ask me, how do I move? How do I migrate? Then they ask me, what does it cost? Because that is a bigger headache for them. The actual prices becomes, a second discussion, not the first discussion. Okay, so highlight reel. Please come back next time for the CAS solution. If you need any more information on CAS and you can't wait until the next time, I am available. You can contact me. We can set up some demos for your customers. We can show them how it works. We can put their mind at ease with regards to the history of CAS and so on, so they can understand they're not left out in the dark. Now, CAS, by definition, Cloud Access Systems, that's the name, is a building block in our cloud product. So if I can go back to my Lego analogy earlier on, CAS will be the red or the green block in our cloud product as well. So when you purchase HCI, you purchase cloud, you automatically get CAS in it. And all the benefits of CAS is getting passed on to you within this infrastructure or this product as well. So you still don't pay per core, it's only per CPU. It is a perpetual license and all those kind of things. Now, we started our cloud journey um, quite a while ago when Zen Server was still something that was really in the fore. And I remember that from my Citrix days back in the day. Um, a really good hypervisor, and it worked extremely well. So from those days onwards, we've had a cloud solution. We have now we've now scaled that, and we are at our version 7 of our cloud solution. Now, this is where we start combining our infrastructure and platform as a service, and make things like Kubernetes and Docker and all that, make that available. I want to just highlight and tell you that the cloud product that we have is a private based cloud. We do not have an H3C doesn't have you know a cloud in the country that we sell often. It's not a hyperscaler. We don't have a hyperscaler offering. If you want a H3C based hyperscaler offering, then go look at Alibaba, because H3C is actually an Alibaba hardware supplier. I think 80% of the service that's in Alibaba at this point in time is H3C service. So, and they have the correct offering when it comes to the hyperscalers. Why our cloud product is extremely attractive, especially in South Africa, is the mere fact that we pride ourselves that we do not replicate any data anywhere unless you want to. So if you're building a cloud solution in the country, the data sovereignty rules all, all apply, which means that uh, because the data doesn't leave the borders of the country, you comply to the POPI Act. Government is also very interested in this. I'll tell you straight out. We are having discussions with some government departments. We have two of these cloud solutions already running, and a third one being installed as we speak. So let's take when we started with the servers, the Xeon CPUs, we then moved on to the more of the power resources, what you cooling and all those kind of things. And we put all of them together uh, into a one solution, something that we've built all together. It would ultimately end up in our cloud product. And all the products that we discussed earlier has got some representation in the cloud solution. Now, I'm not going to beat cloud to death. I completely understand there is a place for everything in the world, and sometimes cloud is the way, and sometimes cloud is not the way. But what I want to bring your attention to is the fact that you will find a lot of customers are looking to do something with multi-tenant, and they are looking to do something with billing and bill back, maybe into departments, not even outside into different customers, but maybe into department. And this is where our cloud product becomes a very, very good solution. We also have gone one step further, and we offer something we call Cloud Light. Now, Cloud Light, when we take our UIS solution, our hyperconverged solution, we install 3 virtual machines onto it, and then it becomes a cloud-like environment with multi-tenancy and billing and those cloud features. So very, very, very good solution going forward. I'm also not going to dig too deep into that because that's another specialized uh, thing that I wanted to talk to you about. So I guess today the idea was just to give you an overview of the maybe more of the hardware, but just whet your appetite with regards to the software solutions that we have that will be focused going forward. So if you look at that as a selling platform, like we discussed, the foundation, we spoke about those, the generation servers, um, the entry point into the cloud journey, or the hypervisor will be CAS. When we start bridging the cloud native HCI virtual machines with containers and AIs and so on, we put our UIS version 8 on top of that. and then we want to take it to a hybrid cloud or with tenants billing and a cloud-like experience where you get a service catalog and spin up a virtual machine like you want to, or tear one down if you don't need it anymore. That's where we bring Cloud 7 into it. And if we look at the secret source, and that's where we run everything in a pervasive, intelligent, self-optimized infrastructure. And that is exactly what it is, the secret source. And we've got, and if you think about it, when we discussed it, there's AI represented in each and every one of them. The version 7 service has got AI into the HDM. There's AI into in UIS. The cloud depends on AI for orchestration and all those kind of stuff. And everything on top of that is built on an open standards ecosystem. And I want to just take a minute and make sure that everybody understands that, because I have seen and I've interfaced with a lot of people that think that H3C is a foreign server that you need special skills to deploy. Our CAS environment, you need to install a version of Ubuntu and then install CAS on top of that. That is not the case, guys. It is an open standards system, ecosystem that you are used to when it comes to Dell and to HP and to VMware. It is not something foreign. Um, and it was quite weird, strange to me when people asking me for CAS. Okay, what do I need to install first? You don't need to install anything. Download the ISO file, mount it, and install CAS, and off you go. Now I think I've got about 5 minutes or 7 minutes, if my timing was right, I've got left. So I want to leave that open for any questions or any remarks. Also, anything that you may want to see um, going forward, maybe in next sessions. I know that the CAS one is going to be next, and I'm hoping for a good attendance there as well, because it's very, very cool. But if there's any comments or any questions, please, guys, let's take these few last minutes to have a chat around that.